if your application is storing personal information like email, phone numbers, addresses, and more, you have to make sure that you don't ignore one rule, that is keep them safe and prove that it is gone when the user is asking for a deletion. In real world, it may sound obvious, but it's way hard to get this done. Because deleting a user information is not just deleting a row in the DB. You have to make sure that it is really gone, not hiding in the logs, not hiding anywhere else. Because when the user or the regulatory comes asking for it, you have to prove with evidence that it's really gone. And today in this video, we'll be talking about how to design such a system that protects user personal details and also complies with regulatory standards. So let's move forward. Okay, so there might be a question as well, like, does this even matter? Do I have to learn all these things? Can't I just build an application with database back in your front end? Of course you can. But when you level up and start building more consumer facing application in scale for enterprises, these things are really important because they will be dealing with a lot of legal compliance as well if you don't. So because there are certain data protection and privacy act or compliance standard for the user, which invokes a right to be forgotten privilege for the user. And in many regions like Europe, they have GDPR standard, and in California, they have CCPA standard, which enforces these rules on how companies can store and handle and delete user data. And every company who are serving the customers in this region should obey them. And in India as well, we have something called Digital Personal Data Protection Act, or DPDPA Act, which also has rules around users' consent, limiting data use, and deleting personal data of the user when they actually invoke it. So it's very important to consider them, and just marking deleted as true in the database doesn't cut it, is not sufficient. You have to make sure it's actually deleted, and you have to give them the guarantee and prove it that it's gone and it's not hiding in your audit trails or your logs, server logs or somewhere. Okay, so this is very important. So the next step, we'll actually learn how to design and how to build it. We'll learn a couple of steps. It's very simple to get started with. And we'll also see a demo on how this works in the real world. Okay, let's go. Here's a few key ideas that will make your application compliant with these privacy standards. The easiest way to get started is tokenizing and encrypting. So you have to decide between what kind of approach you have to use. You can also add hashing here. So for fields like email addresses, card details, full name and everything, you can use tokenizing and encrypting for this, because it's two-way. You might have to get the original data back for processing later using a decryption key or something. For example, if you're showing a profile page of the user, you need their email back, right? So you can decrypt it using a key. So this is two-way. One way, a best example of one way is password. So you hash the password, store the hash, and whenever you want to compare the password, hash the incoming password and then try to compare the hash. The hash matches, the password is correct. If not, it's incorrect. That way you can use one way, that is hashing. So this was the first thing. And the next thing is safe logs. Make sure, no matter what kind of logs it is, make sure you're not logging user data as it is over there. Okay, so you can try to use user ID which you're using in the DB. Okay, that is safer way, to be honest. Try to circulate user ID in every log if you want to log something related to user. But for some reason, if you want to use their full name or let's say email address or something, try to mask it. Okay, mask it in a sense, add XXX over in between the email or at the end of the email and everything, so that it's unreadable. So if in case the logs are leaked or someone else is looking at the logs, they won't actually read the entire email. Okay, it should be unreadable. The next thing is build a delete path. Make sure you have a clear plan regarding a deletion. So when the user clicks on delete, you have to make sure you remove and disconnect any personal data you have linked with any systems. And if you have any third-party system, make sure to invoke deletion from their APIs as well. And make sure to delink every relationship you have within your table regarding that user, and make sure it's completely wiped off of all the logs anywhere else that you have maybe sharing these personal details with. Okay, and the next thing is keep an audit trail of every single thing. Any of these key events occurs, you have to make sure you're logging that in your audit report. Okay, and you can also improve this audit report with a proof hash. I'm going to show you what that is. Okay, for now, just think about logging every single thing that happens, at least the key events like this. Okay, now let's move on to the demo. We'll actually see what we are kind of talking about, and then we'll actually see the code. Okay, let's move on. Okay, so before we jump into the project, I want to give you a little bit of context about the entire code base. Okay, so the first thing is this code base, it's not something very complex or something new. It's just your simple project like a CRUD application project. Okay, so we won't be actually coding this from scratch because it doesn't make any sense. It's just your usual application which has a DB API and everything. But I'm going to show you the crucial aspect of it where we're actually tokenizing, encrypting and all those stuff. Okay, the first thing is I have a simple JSON databases over here. You can see DB JSON where we have user and an audit JSON as well where we're storing the audit report. This is very important because whatever the interactions we make in the demo app, that will be reflecting here. Okay, now let's jump into the demo. Cool. So we have a CFDD demo over here. Okay, so I'm going to create an application right now. Okay, so I'm going to say pavan.test.com and then I'll add some random phone numbers. Okay, and then I'm going to add my password here. Sign up. Okay, so account was created. Now let's go back to our code. Okay, so if I go to db.json, you should be able to see my details here. So this one is some pre-filled user. Okay, it's an admin user. You can ignore it. So this was the user that we actually created. So if you look at this, there is no indication that this actually belongs to me, right? This actually belongs to Pavan. So even if this database gets leaked, the hacker won't be able to understand anything from this database. So this is how we're securing everything. So all these name, email, phone number, and all these are encrypted. Okay, so we are encrypting using this crypto function we have. So we can see here encrypt and decrypt that we've written. Okay, and we are using an encryption key from here. Okay, so we're encrypting every single thing, and this key will be secured in case of real application. You'll be using some providers like HashiCorp Vault or KMS, AWS KMS. So you'll be using services like this to secure an encryption key. Okay, so this way you can make sure that the user data is not tampered with. But now let's try to log in. Okay, let's see how can this decode entire thing and then log me in. So I'm going to say pavan.test.com. I'm going to log in over here. See, login was successful. Okay, and then I'm going to get my profile, and you can see profile was successful. So it was able to decrypt that my data and show me because it recognized that I was the actual user requesting for this. And if I copy my ID over here, go to audit and try to load my audit logs, you can see I got one audit log, that is user account created with proof hash. I'm going to explain what is proof hash. So now let's try to delete my data. So I'm going to delete my data, and it says your data has been deleted successfully, and here's the proof hash for that. Okay, now if I try to go to my audit and load the same audit logs, you can see initially I sent the delete request. It says user requested data deletion and then data purged. Purged in a sense, it's completely removed. Okay, so all the fields like name, email, phone number, password, everything was affected, meaning it was removed. And PII data and password hash as purged, backups corrupt. So even the backups was corrupt. So we didn't store this anywhere. Okay, and this is a proof hash as well for this. Right, here's a proof hash for this one as well. All right, now coming back, let's try to load the profile again. It says user not found. Okay, so let's ignore this. Let's go back to code. So here, now you can see I have the user details here, the ID of the user here, but the entire thing is null. So everything is completely purged away from the DB. Okay, and if I go to my audit JSON, you can see in audit report, we have every single thing here and also proof hash. So what exactly is this proof hash? So let's go to server.ts file over here. Okay, the first thing I want to teach you is this one. So before actually creating the user in the DB, you can see I'm encoding or encrypting, not encoding. Again, there's a difference. I'm sorry, I said encoding, it's encrypting. Okay, so I'm encrypting name, email, phone. I'm creating an email index. So I'm creating an email index so that it's very easy to look up, because when you encrypt it, it becomes some weird alphanumeric string, right? So you need to have an email index. Okay, email index can be hash of the email to look up the user using email. Okay, this is for database operation. Then we have password hash as well. Okay, so every single thing is being secured here. And then we are actually storing it in the DB. Then we are actually adding it the audit report. So in the audit report, I'm going to say this is a user creation record. Okay, and the proof hash is here. And similarly, we're creating a proof hash for everything, right? So I'm going to show you the proof hash of the deletion and how to verify it. So this was deleted. Yeah, this one. So data was purged, right? And then we get proof hash. So in the proof hash, what we're trying to do is we are trying to use the user ID, then the action called data purged, and then deletion method is overwrite. And affected fields should be name, email, phone number, password hash, because these are the 4 personal details we are accepting from the user, right? And then the timestamp of today, basically whenever the data was deleted. And this all will be converted to hash. And now assume that some user tried to sue you in the court saying that they are retaining my email, their proof is invalid. So what you can do in the court is you can say, if you try to rewrite this object, let's say in a JavaScript object or a plain text, if you write this user ID, which is already in the DB, and you can get that and add this action, like if you try to write this object separately, okay, separately like this, okay, and then hash this and compare that with the proof hash that you got before. If it is same, then all these data were purged. okay, then the code can say that safely that yes, since the hash is same, all these data has been purged. Okay, but if this data is not same, then you won't be able to find it out. Okay, I mean, you can find out that the company has been lying for you, that they didn't delete your entire details, they did save some of the details. Okay, and you can actually improve this, take it a bit more forward with actually adding database fields or something like that here, or maybe include more proofs also to make it even more secure, or what do you say, even more, give it even more creditability for this proof hash. But this was just for the demo. Okay, but you will actually add some more details for this, some more metadata for this, proving that it was really gone. Okay, so this is something that you would implement. Okay, if in case you're building large scale consumer facing application, it's not required for every application you use. Okay, your application like Razorpay, your application like whatever the application used with Google, Microsoft and other SaaS application, right, they all follow these because they have to be compliant with these standards. All right, so with that said, let's move on to understand how this affects in the real world. You know, in the real world, when you're compliant with these standards and you actually add a badge in your website saying that you're compliant with these type of standard and you've actually been audited, because there are officials who will actually audit your application and give you that recognition saying that, okay, this particular application is compliant with so and so standards. So this will give you a large boost in case of, let's say, acquiring a lot of users or securing funding or growing your business as well. So it's very important as a developer to understand these concepts, because you might get hired for a company and your boss might come and ask you, we are thinking of building an application that's compliant, so design for compliant application, or database should be compliant, something like that. Okay, and these details would turn a good system into a trusted one, because no matter how fast your API can respond, but if it's not trusted, then it has no point, right? And with that said, thank you so much guys for watching. I really hope you guys learned something, and do follow us for more of such tutorials, because we keep coming up with content that not many people are putting out there, and we teach you how to become a good developer, how to become a good software engineer and build a resilient system that is more compliant, fast and secure. All right, thank you so much guys. Subscribe and like, and do comment if you have any ideas and want us to look into it, and do share it with your friends. All right, thank you so much.